Today we have Jeff from AISD to talk about SafeML modeling language.
Hello everyone, I'm Jeffrey Biggs from AISD, and today I'm going to be talking to you about how you can use SafeML to improve the traceability of your safety information. So I'm going to start with part one, which will explain the goals of what I'm going to be talking about today and the background about the work we're doing. So the problem that we're dealing with is that safety information is extremely difficult to manage during the development of a safety critical systems project. This is due to various factors, including the complexity of the information. It's dealt with in various different places, in different formats, and with different people. There is also communication problems between these people managing the information. For example, this information is communicated during meetings or in textual reports, which is very time-consuming and ambiguous. And finally, these factors mean it is a large cost and in terms of time and money to develop and maintain this information. And this means that overall safety information management is a very complex, difficult task. So this slide shows an overview of the flow of safety information during the development of a safety critical system. In the middle we have a system engineer. He's developing a system and he's going to be responsible for designing it, producing the requirements and so on. And based on the requirements that he produces, a safety expert is going to produce a safety analysis, which is going to produce a list of things like the hazards and the risks and so on involved in using the system. And this is going to be combined into a system model, which will hopefully take into account these hazards and risks to produce safety features and therefore make the system safe. Based on this, we need to produce a report, which is then delivered to a certification agency. And this agency then tells us if the system is going to be guaranteed to be safe or not, and we can get certification and begin selling that system. So there are problems here where we've proven through real-world experience that these manual text and voice-based exchanges of information are very ambiguous and lead to errors in the safety information. And furthermore, when any of this information changes, because it is stored in many places, as we see here on the slide, it is very hard for us to update it in all those places and maintain the consistency of the information. This makes judging the impact of a change in the system, such as a new hazard being identified or a new safety feature being added, very time and resource intensive to get correct. So our approach to solving this is to apply model-based methods. In this case, we're using model-based methods to manage the safety information. So what we're doing is we're adding the safety information that we've produced into the system model and recording it there. To achieve this, we've created a modeling language that we call SafeML, for Safety Modeling Language. This is a tool for communication of safety information amongst members of a development team and amongst the agencies involved in safety certification. It's based on the SysML, which means it can be integrated completely with a system model. And SafeML is developed based on both international standards for safety critical systems development and on formal safety analysis methods. So as we see on this slide here, you can see where SafeML is useful. We have our model-based system done in SysML, and we have SafeML being used to model all our hazards and risks and so on that we've produced from our safety analyses. So this is then integrated together into a single system model using SysML and SafeML, which produces a system model including the safety information. This has several benefits. First of all, the safety information is only stored in one place. This means that when it needs to be updated, we only need to update it in one place. And because it's model-based, the computer can then automatically update any other products produced from that model, such as reports. We also gain the benefit of automated computer assistance. Because we have now made the computer understand the format of our information, we can use the computer to perform analyses. For example, we can perform an impact analysis to determine what parts of our system are impacted by a change in the known hazards. Or we can use it to generate the very large reports that need to be delivered to certification agencies, reducing the time and manual work required in managing safety information. We can even change how we display this information to suit the task. When you have textual reports and tabular reports of safety information, it is very hard to change how that's formatted to suit how you're using it. So instead, with SafeML, we can automatically change how the computer displays information, such as tabular views, matrix views, and model views, to suit what we're doing with the information.